Okay, so last week we spent a significant amount of time talking about the process of creating a skeleton and then, of course, binding that skeleton to the mesh, okay? That's not it. That's not all the rigging we're going to do for this thing. In order to create a really functional control rig that provides the level of detail and deformation that we're after, we have to start adding a new layer to this, okay? So our conversation today is going to revolve around inverse kinematics, and we're going to increase the complexities of our skeleton rig pretty substantially, okay? This is one of those parts in our grand kind of rigging, element, if you will, okay, that's very sequential. And if we break that sequence, it's just fundamentally not going to work, okay? So to help you guys out, and a number of you guys have already stumbled upon it, I've given you a really great learning resource here that is that sequence written down, okay? Because this is where it gets tough, okay? If you really take a step back and look at what we're creating here, we are absolutely creating a little machine, okay? So the sequence that we create that machine is really quite crucial, okay? So please make sure you download that. Those are yours. I want you to use it going forward. There's nothing magical about this. It's just a PDF, okay? So it should load on every machine that you have. Print these out, or at the very least, bookmark it somewhere inside of your internal library, because you're going to want to come back and reference this a lot, often, okay? We're going to practice this a couple times today so that we start getting a more kind of direct understanding of the sequence. It's important that we go through these sequences a number of times to really kind of codify it and solidify it in our minds, okay? Now, to help us out in that process, I've given you guys a really cool little lab assignment. So if you turn to the week 7 section inside of Canvas, here we go, basic leg, inverse kinematic. Let's begin here, because in every sense, this simple little leg file will allow us to kind of refresh our memories as to the creation of the skeleton, how to bind things, and then most importantly, it'll give us a nice little playground to learn the ins and outs of inverse kinematics, okay? So, if you download the project file, let's just do it real fast. Let's get going, huh? All right. Let's take a look at the file. Now, I didn't make this model file, so I can't take credit for its awesomeness. If you look at what we're working with here, it is just a leg, okay? It's not a whole lot, and it allows us to focus on really the concepts that we're striving to really master today. So if we jump over into the Setout tab, FYI, I had this question during office hours this week, and I think it's a good thing for everyone to really kind of notice and learn, because it's going to help. I think it's really going to help folks kind of understand and consume the contents of your scene a little bit more directly. So the question was, Pat, what in the world are these viewport textures? Okay, has anyone stumbled upon this? This is a new thing that popped up in the most recent version of Modo. The viewport textures section allows us to add an environment, image maps, mat caps, any number of things into our scene without having to isolate and filter our entire project files with a whole bunch of materials. So think of them kind of like temporary materials, with the idea that we're just using them in this viewport temporarily, okay? So they're pretty neat. I've been using them kind of regularly because I love mat caps. I think mat caps are really kind of cool. They allow us to change the shading style of our environment a little bit to make it easier to see what's going on. The process of applying a mat cap in the shader tree is not difficult, but man, this viewport textures thing goes a long, long way. It makes it go really fast. So I'm going to go into mat caps. And the way this works inside this viewport textures area is you can click on any of these mat caps or the image maps, by the way. So any of these things, environments, UV textures is kind of fun, because then you can actually put on, this thing doesn't have a UV map, so it's not going to work, but you can temporarily kind of put an image onto your UVs without having to create a material group. It's just kind of neat, right? Anyways, let's go back to the mat caps, because that's what I'm going to do. And the way this works is you can just double click on any one of these spheres. Of course, mine's going to choose not, oh, it's going to crash, which is even better. Let's try that again. Take two, right? Cut. I'll stop the live stream. No, I won't stop the live stream. Let's go back into it. It's just one of those days for me. Now I'm also going to change my viewport shading parameters here from shaded to default, which will take advantage of the OpenGL architecture inside of Modo. That may have been the source of my crash. Let's do it again. There we go. You double click on it, you can see that now we're applying what's called a material capture to the object itself, and that's pretty neat. I like these matte caps because oftentimes, getting a good solid understanding of how the reflections are influencing the topology of our mesh is really helpful. I find that this reflection map is just way too much for me. There's too much contrast in there for me personally. So the map caps are a great way for us to go in and get a better understanding of how this looks. Now, if you don't want to use it, or if you're done with it, just return to that same drop-down area and then just hit none. That's the part that people miss, right? If you want to turn it off, go back to none, and now we're back to our standard environment, which is kind of cool. Okay, very helpful. This UV textures thing is great. It is great for when you're doing your UV mapping, and you'll see this a lot in GCOM 424, right? It allows us to very quickly preview our UVs, see how we're doing without having to create a whole new material and tag things. It saves a couple additional steps, which is kind of nice. Makes it simple. All right, I'm going to go down. Some of my favorites are at the bottom. There's a whole bunch of them. I like waxy red personally, and that's the one. And I just like red generally. So this is where we're going to work. Okay. Cool, huh? A lot of fun. All right. So this is the mesh that we're going to be working with during kind of our lab exercise today. And as I mentioned before, this is going to serve two purposes. A, refresher, kind of remind ourselves how we create a skeleton and bind it to the mesh, okay? Because that's an important sequence. And we'll start looking at how we can infuse inverse kinematics into our skeleton to get the level of deformation that we're after, okay? All right, so let's get into it. Where am I going to go to add all the skeletal joints inside of my scene? Setup. You got it. So I'm in the setup layout, which is pretty cool. And of course, the setup tools at the top of our toolbar are going to give us, once I click on it correctly, the skeleton tool itself. Okay. Now, a couple things that folks have been working and running into is the orientation of your joints. Okay. Here's a good, solid tip. Okay. Do it in orthographic views. That helps the computer understand, and it actually uses the work plane to place the joints along a particular axis. Okay. So that's a good suggestion. That solves 75% of the problems, okay, pretty instantaneously. In addition, make sure that a line is z direction, x-axis. And what that's going to do, it's going to put the z-axis going down the chain. And you'll see that here in a second. Let me just go ahead and start it. Now, I'm going to create a root bone out over here. And then let's do this. I'm going to look at my mesh from the side because I got hips. The knee is kind of geometrically undefined, so we'll put the knee right there. And then for today, and this is something that's a little bit different from what we talked about last week, let's create a more detailed foot, okay? Because feet require some energy, and we're going to spend half the day talking about feet, okay? Believe it or not. Because ultimately what we're striving to accomplish in this moment is this kind of movement with our feet. We want to be able to take the heel off the ground, but have the toes and the ball of the foot stay right where it needs to be, okay, on the ground. So that middle deformation is important. And we do that, or we can achieve that quite easily by putting a joint, let's see, where's the ankle? Right about here-ish, okay? So we'll need a joint at the ankle, and we'll need another one right here at the ball of the foot, and of course we want the termination joint at the toe of the foot, or the tip of the foot, okay? I may have placed the ball a little bit off. There we go. Now, if you look very, very carefully here, you can see that we always have, on all of these joints, we always have the z-axis shooting down the joint chain, okay? That's what we're after. We want to have a common axis pointing to each other. The z indicator line of the first joint, or root, is pointing at this guy, this joint, the center point of this joint. This, my hip joint, whoops. My hip joint is pointing down to my knee. Z indicator line for the knee is pointing at the ankle, so on and so forth, okay? That's what we're after. Now, before I drop the tool, I think it's a really good idea to make sure that we're aligning these in a couple different views simultaneously, because I'm clearly way off. Let's get this lined up here. Now, for the ones up here, in the middle of the foot, that's where the top view kind of gets real handy. Let's just do another solid look, make sure things hasn't shifted too much. Yep. Something like that. I'm being a perfectionist because I can be, and that's good enough for me. I'm happy with that. Okay, that's a good skeleton. Good skeleton. Okay. So mission accomplished on the skeleton. How do we bind this little skeleton to the mesh? What's the process? There's a sequence here. Yes, sir.
Well, first you have to, one must select the bumps.
Got it. Yeah. So the step numero uno, of course, you're going to want to do this in item mode, is click on the joints, right? Power user trick. This is something that we talked about last week, but it's a good one to commit to memory. If you double click on the root joint, it selects every single joint that's a child of the root, which is kind of cool. Okay. Because heaven forbid you have to just click on each one. That'd be just like mind-boggling. Okay, Liam, what's next?
Well, next you have one. You gotta select the bones and press and hold Control.
Yep.
And select the mesh.
You got it. What was that?
Oh, sorry, that was me. I'm on my OneDrive, and unfortunately it has Skype on.
Unfortunately, it has Skype. Okay.
No, I want to get rid of it.
Yeah.
I don't like Skype.
Yeah. I'm sorry, say again? It's probably because it's open at the top, which is fine. We can fix that.
I'm sorry about that.
Yeah, thank you. So, of course, we got to select the skeleton first and the mesh second. Okay? Then what? Third step in our little sequence.
Do we enter setup mode?
Setup mode's next, right? That's the next step. Got to enter setup mode. And then, bum, 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 bum. Where are we going? Deformers. You got it. So way down here, oops, I passed it. Inside of our toolbar, we have the Deformers collections of tools, and you can see at the top, we have bind. Now, right now, if you use probably most of them, if you do heat, you'll get an error saying, topology error, vertices cannot be shared by non-contiguous polygons. Illegal vertices have been selected. So it should be, if we go into vert mode, oops, not even letting me doing it. That's okay. Let's try it again. Grab that one. Oops, I am, double click. Now my bind is completely not turned off. That's awesome. Let's try this again, huh?
You have to enter setup mode after
Yeah. All right, so let's do smooth distance. Yeah. The heat bind type really, really wants to have, as much as it can, a closed mesh, right? This mesh is open. If you look at the top, of course, naturally, there's a gigantic cavity where the hip would be. In addition, and I'm going to hit undo just one level here to go back in time. If you look at the opening, or the actual leg itself, it's open down there, right? Now, a lot of folks think that when you're working with the rigging tool set, everything has to be one contiguous polygon. That's not the case, right? We don't have to have every single piece welded together. And this little leg example is a perfect illustration of the idea that we can have separate pieces. And we should have separate pieces, okay? Let me bind it again real fast. Smooth distance is a good one to use. If the magic of the heat bind type doesn't work, try smooth distance. It's a solid second choice. Smooth distance is going to require a little bit of extra love, as they say, when it comes to the skin weights, okay? Heat, seemingly, is magical, right? It does a great job of collecting all the verts that are relatively close to a joint and assigning it to the influence of that joint, right? Smooth distance, however, not so magical. It's pretty unintelligent, actually. And it requires a little bit more finessing, maybe is the right word, to get the paint rates and the skin deformations where we want them to be. Okay, so let's just hit OK. I know I've been successful in my endeavor because I got a rainbow leg, and that's what I'm after. Okay. All right, so we have created a skeleton. We've bound the skeleton to the mesh. Let's make sure things are working by exiting setup mode and start moving around our leg. Uh-oh. Why is that not working? Let's find out. Not working at all. Oh, wait, that might actually be my fault. I turn off my deformations. No, Enable Deformers is on. Why is that not working for me? Well, that's not fun, isn't it? Maybe it has everything to do. Well, I just got an idea. It's just going to be one of those days. All right. Yeah, no, it did it to the leg. It did exactly what it should have done. Why am I not getting the deformation that I'm after? Does someone else get the same thing? Am I the only one? Yeah, it's working for everyone else. So it's just me then. Here, let me do this. Because I think maybe hitting undo perhaps a number of times screwed me over. I've learned that. This is the challenge of my daily environment, right? All right. Teaching and doing when it comes to rigging are incongruent at times. All right. Bear with me for just 2 seconds. I'll very quickly get us back to the example that I had before. All right. Won't be as pretty, but you know what? Today, I don't care. All right. All right, there we go. Let me just get this back to where I want it to go real fast. Go. Exit setup mode. And this better work. Otherwise, I'm just going to really scream. There we go. All right, back in action. Ha! Wonderful. Okay. So now comes the ever painful process of going through and adjusting all the paint weights, right? Now, this was an issue for everyone probably, right? Or at the very least, a minor annoyance, okay? Yeah, because it really is something you gotta go check every single joint, okay? Assuming is relatively a bad idea when it comes to adjusting your paint weights, yeah.
A big difference for me was turning off live deformers.
Yeah, the performance thing, and this is a common complaint inside of Moto. The performance is not awesome, okay? Turning off live deformers, okay, really helps, and we'll talk about that here in a second. Yeah.
I also found a neat little trick. If you do all your weight mapping in the setup mode, it runs a lot smoother.
It does, yeah, because then you're not trying to actively deform the mesh in real time in the viewport itself. Yeah.
Yeah.
Yeah, we'll look at that here in a second. Some efficiencies. Yeah, Adrian. Yeah, absolutely. Yeah, for sure. And if you really take a step back and look at it, there's a couple of things that we can do, and this is where the mad scientists kind of come to the foreground, right? And a lot of high-end rigs, you've actually already done this a couple times, right? If you go back to the opening and closing of your car door in the earlier example, the set-driven key process allows us to basically define a range of movement, right? We do the same thing here with our rigs, okay? Yeah. Okay. Are you in setup mode? Adding on setup mode. Yeah. So you kind of ran into the same thing. Oh, you're in setup mode still. Exit setup mode. Now try rotating it. There we go. Yep, mission accomplished. Let's take a step back for a second and look at the paint weights here, or the skin weights. The weights. Everyone calls it a little bit different. And really get a good solid understanding of what these things are doing to my mesh. And now's probably a good time to turn off my map caps so I can very clearly see the range and the influence of my weight maps around the relative joint itself. Okay, so this is where we kind of have to step in and say, okay, what do I want? How do I want my mesh to behave? How do I want it to deform and bend and warp around certain areas? If you look at what's going on in here, this is kind of an odd deformation. The envelope is really collapsing in a strange way in the back of the knee. Now, if you think about it, as the skin folds, the area right above it shouldn't be folding that much, okay? We almost kind of want to have a hard line in here, so that's a good place to go in and start making some adjustments, right? Whenever I'm working it, the first thing I do is just kind of generally do a spot check and see how it's all put together, okay? Yeah, this is a really great example of where the weighting system has really kind of screwed me over a little bit, okay? I move my toes, and I don't want the verts around the back of the heel to also move, so I need to go in and make a few adjustments here, okay? All right, so a couple seconds ago, people were talking about how to make this process go a little bit faster, right? Let's go into our weighting tool set and begin to explore how we can adjust the vertex map and the weight maps that's associated with this joint, because I don't want the back of the heel to move and rotate, okay? That's a problem for me, okay? So here's a couple things, okay? Live deformers, if you turn that off, your performance is going to spike pretty quickly, okay? You're going to get a much better response with the tools if live deformers is in fact disabled. Yeah, and this is a big time complaint of Moto. They've been saying this since the first day the tool set was introduced, is that the deformation system is not as fast as it should be. So I feel your pain. This is if the developers are listening to my live stream, you know, they need to fix this, right? However, turning it off will give us the response that we're after. Now, there's a great way. I like adjust weights. Adjust weights is a great, fantastic way of very quickly making some sweeping changes to the map or the weights on my vertex map. So I'm just going to go into vert mode here. Select some polygons in the back, and I'm going to adjust them. Okay, and I want to put them at 0. The cool thing about this, if you left click and drag with this tool on, you can see they can interactively adjust the weights for the selected verts. That's a cool way of very quickly kind of nuking things out and returning, or assigning their weight value quickly, okay? And in kind of an interactive fashion, which is kind of neat. However, it's not the only way that we could do this. Last week, one of the things that we talked very directly about was the paint system. This is kind of cool. It's a lot of fun, okay? I like going in and painting. This is where the artistry, if you will, of skin weighting really comes to the surface. We can use a whole series of paint strokes to assign the values, and I'm going to turn off my selection here real fast. Okay, so the part that a lot of folks get kind of confused about is the value you're painting down, okay? Remember, we're working on a 0 to 100% scale. If a vert has 40% influence and I paint 50% on top of it, what's the new weight value of that vert? 90. This is additive, okay? It's additive. If you paint 0% in there on the same vert, what's it going to be?
0.
40. 40, okay? Now, if I wanted to subtract it, what would that number have to be? Negative. Right, you got it. Okay? Let me illustrate this idea pretty quickly for you guys. Okay? So I can go in. There we go. And with live deformers off, you can see that I don't get an update bloop, until I mouse up. Okay? That's what that live deformers option is really going to produce for you. Let me show you specifically what I'm talking about. If live deformers are on, then whatever I paint is a little bit more interactive. Kind of acts like a paintbrush now. Okay, awesome. That's pretty cool. Now let's put this to like -50. Okay. Now we're subtracting stuff. Okay. So if you want to add, have it be a positive value. If you want to subtract, have it be a negative value. Okay. Now at times it's kind of tough to know how well of a job you're doing, because when you get closer and closer to 0, okay, it gets fainter and fainter and fainter, right? What's a great way for us to help visualize the values that we've been painting on? Because this is cool. This is a great way of working, okay? if we're overlaying our weight maps on top of our mesh, at times, depending on the mesh, it's tough to see. Here's a great alternative, one that I suggest folks doing probably more often than not, is just changing your viewport shading style to Vertex Map. Okay? That way, it's a little bit easier to see what's going on. In addition, some other visualizations or some other tweaks to the environment will help you understand and visualize your weight maps. Something that I do, I almost always turn off my grid. I don't have my grid on unless I really, really need it. It kind of gets in the way 9 times out of 10. If you have a really good understanding of your spatial dimensions, there's no reason to have it on. So I'm going to put show grid to never. That's helpful. In addition, this is something that I do kind of often, is I turn my wireframes off. Now I'm in the active meshes section, and changing the wireframe overlay from uniform to none helps too, because now we can see pretty clearly where I need to work. Okay. Looks like I got some problem childs in there. I'll fix that here in a minute. Okay. There we go. Now, one of the reasons I like working with the paintbrushes is because we get a nice kind of smooth gradation of values, right? It's not off and on. When you have verts that have a 0% weight next to a vert that has 100% weight, it's going to clip, and you're going to get a really odd deformation in the middle of the polygon, right? So being able to modulate and apply down a gradient of values across our polygons is really kind of an attractive feature for us. Let me show you something here. Let's do this. And this is where I need to have my wireframes back on, so bear with me for a second so I can make some intelligent selections here. Yeah, I'm going to use those edges, and I'm going to do set value. Oops, I'm in the wrong one, sorry. I want adjust weights, put that to 0. You can also do this in edge mode, by the way, which is one of the things that I really like. I want to make it really extreme. There we go. Looks like I missed one up here. There we go. Okay. So one of the cool things that we can do is that we can use edges very quick. Yeah, question, go ahead. You can't paint. Okay, let's check it out. What did you change before? Okay. Okay, now, well, you get select a joint first, right? Select a joint first. Yep, there you go, okay? Now you got to tell it what to adjust. Okay. Just weights. Now if you left click and drag, you need increase and decrease. Yep. Left clicking and dragging will. There you go. Okay. So that works. Let's go back to our tool set and see if we can start painting in there. Now, it probably has a lot to do with the values that you're painting. Go ahead, drop your selection, because we're only going to, if those are the selected verts, we're only going to paint on those. Right now, drop your selection. Okay, there you go. Grab the paint tool. Let's look at the properties. So it's at -50, right? Yeah. So go ahead and start painting on top of it. Now, mouse up. There it is. When live deformers is off, you're going to get the response when you let go of your mouse. Okay? So if you turn live deformers back on in the command section, you'll be able to see the interactive paint strokes. On complex rigs with a lot of polygons, turning off live deformers is going to save your bacon. Okay? Also, doing your painting inside of setup mode is another great way of working. Okay? One of the cool things I like about working in setup mode is that, or painting our skin weights in setup mode, is that I can do a big change like that. Now that is wacky and weird. Okay, I can have the deformation in my, on my rig as it is here, and then I go back into setup mode and I can make changes. Right. All right. So let's throw down some values here. Let's put this at, I don't know. Let's put it at 10. I'll just slowly add in a nice little gradient of values. Okay. Now, where I was going with this, and what I was going to talk about a couple seconds ago, is that there's some other tools that are really important to focus on. Smooth is a great one. Okay. Smooth is going to allow you to select some verts or some edges, and then we can start smoothing it out. which is going to start to relax its weight. Okay? It's a nice way of making a transition between two zones because we don't want to have the transition be like 90 degrees, or excuse me, like a on-off, 0 to 100. Since I was doing this editing in setup mode, the deformation will become live and active again when I return out of setup mode. Okay? So it's a great way of kind of making an adjustment and then seeing how that adjustment impacts the mesh over here, because I got some weird deformation happening. Yeah, I may want to go in and add some more weight values up here at the top. Let's put this to 50. There's a lot of trial and error with paint weights. Okay, and unfortunately, you know, that's the hard part about paint weighting, is that it's just trial and error. You gotta try something, see how it works. Try something, see how it works. Remember that you're weighting a vert. You're never going to be able to weight in between two existing vertices, okay? The whole system is centered around a vert, okay? Now in here, this is a really great example of where live deformers is really going to be helpful, because now I can go in and say, whoa, you know what? Excuse me for a second. Here we go. Now I don't want to adjust weights, sorry. Paint weights. Maybe let's do negative 20. Getting way too much deformation in here. I want to make my brush a little bit smaller. Yeah. An unusual thing that's normal.
So when this moves down here, that moves
Okay,
there.
that's interesting.
Even
So
though it's all set to 0.
let's
up
see.
top.
Let's look at your computer number 9, Indigo. Let's check out Indigo's machine for a second, because this is a problem that a lot of folks, even myself, run into from time to time, often, more than from time to time, right? Is just understanding how the network of bones and their associated weight maps are working together to get the final result. Let's check out the problem that Indigo is working with as soon as it loads. Could be the hip, yeah. Probably, I'm going to guess. Yeah, I'm going to guess it's probably the hip, which is why we got to go into each individual joint. Okay, show everyone your problem, Indigo. You click on the knee, you rotate the knee, and the hip starts to behave oddly. Okay, cool. So let's start exploring the hip. Okay. Let's look. So there's your root. There's that one. That's the hip. Knee. There it is. Yahtzee. That's the one. Okay, it's the ankle joint. Okay? There was the joint below it in its chain that had influence on the verts way up there at the top of the hip. That's the problem. And this is why you got to go into each individual joint in your skeleton, right? To triple check, because the computer is not infallible. The computer will kind of screw you over 9 times out of 10 when it comes to your weight map. So you got to go in there and really, really, really give it the love that it demands, okay?
By accident, because I just finished doing the ankle joint and it did not look like this.
Well, okay, this actually brings us to a really good point. And maybe we can use yours, since yours is, well, actually, I can use mine. The process of normalization. This is one of the elements that I wanted to talk about today. Thank you, Indigo, for being my Vanna White with the problem. We should give it a name, a Vanna White that's nothing but problems. Because Vanna White in the game show, she just stands there. She always brings good news, Vanna White, right? We should have Vanna White's evil stepsister, right? That is the complete opposite. Vanna Black, yeah, something. That's nothing but problems. She highlights the bad things that are happening, right? Okay, so the process of normalization. This is an important idea. If you go back to one of the ideas that we talked about last week, I said that every single vert can only be influenced up to 100%, right? Every vert can only be influenced to a total, cumulative weight value of 100. 10% of that weight value could come from, the hip bone. 20% of that weight value could come from the toe bone, and 80% or 70% of that value could come from the ankle bone. So multiple bones can influence the same vert, but that total cumulative weight value can only be 100. Okay? So what was happening with Indigo is that she had multiple weight maps that were influencing the same vert. Okay? And let's see if I can, and they weren't getting normalized correctly. Let me see if I can. You just painted it, yeah. And I think I saw on your screen the issue at hand. Okay? Let's get that back. Put it back down to 0. Okay, so let's do this. Okay, so let's see if I can rebuild the problem that she was kind of working in, right? So that's fun. Oh, because it got rotated on accident. Oh, yeah. I didn't do a good job of inspecting my skeleton before I bound it. Now I got an odd rotation, but that's okay. Okay, so every vert can only be influenced to a maximum value of 100%. Okay? So if we focus on, let's do a real noticeable feature, and I'm going to do this little knobby thing on the actual geometry itself. Okay? I'm going to grab all of this stuff. Now that's a discontiguous piece, so we'll grab some polygons on its friend. There we go. Okay. That's a pretty noticeable selection, so we'll just keep that. All right. So let's do this. I'm on my knee joint, okay, and I'm going to assign those polygons, the one right at the ankle, to a value of 100%. Just weights, 100%, okay? Now those verts have been assigned to a value of 100% to the knee joint, right? Let's go down to the ankle joint, okay? Notice very carefully that what used to be weighted here has now been removed, okay? Let me prove it to you. Now I'm on the ankle joint. I've selected the exact same polygons, and this is going to be fun, okay? I'm going to assign their weight value to 100, okay? So now all of these polygons in here have been assigned to 100% weight on the ankle joint. If we return to our knee joint, what isn't assigned? Those same verts, okay? So when Indigo was painting on one area, maximum weight for the ankle, she was taking it away from another, okay? Each vert can only have a maximum weight value of 100%. We can divide that over a number of different weight maps, but the cumulative for all the weight maps for that one vert is always going to be 100, okay? So we have to be careful, okay? And this is the thing that I see a lot of folks doing, and at times it's a good idea, but other times it's not. And I'm not outing Indigo because she did something horribly wrong, and actually I see it on Patty's screen too. So it's something that a lot of folks do, right? Patty, real fast, before you do anything, what computer number are you? $17, okay. It moves. It works. Yeah, it's going to work. And what joint do you currently have selected? The hip? Or the root? I can't. The second one, probably one of the hip bones. Okay? Here we go. Okay, so if you look at how Patty has weighted this particular joint, she's basically said this entire leg, all of the polygons that are bright red are going to move at 100% the movement or the rotation value of the hip bone, okay? That doesn't give us any deformation at the ankle bone. We've actually kind of taken the ankle bone out of contention here, right? Because if you were to go in and just go ahead and select your ankle joint for a second. I'm kind of curious to see what it looks like. It's in there somewhere. You may even want to do it in the hierarchy. Yeah. Let's see, is that your ankle? There's kind of your ankle area. Yeah, we have. Yeah, our chain got broken somehow. Yeah, the skeleton chain got broken. If you look at the hierarchy, let's see. You have skeleton joint 2, and then 3. Yeah, skeleton joint 4 needs to be parented to skeleton joint 3. It got unhooked. Yeah. So be careful when it comes to weighting things like this. Thank you, Patty, for being our Vanna Black. We need a copyrighted. I know, right? Yeah. So when it comes to weighting, we really don't want to have weight maps that look like this. Okay, and I'll recreate the example. We don't want to have weight maps that look like this, where one joint, in this particular one, the one that I just did, is influencing an entire appendage. Okay, because it takes those other joints out of the entire equation. Because now when I rotate my hip, yeah, it works. People go, sweet, this is what is supposed to be happening, right? But then problems start to arise when you start to rotate the other joints, and you go, wait a minute, that's not working. And then that one has no weight values associated with it either. Okay, so this is a landmine. Don't step on, weight maps. If you find yourself with weight maps that look like this, big problems. Okay, humongous problems. Generally speaking, this is the kind of attitude that we want to have when it comes to weight mapping. We want zones or bands of influence. Okay, I want to be able to go in and move one joint and have the verts right around that joint be influenced by its rotation. Okay, bands of influence. Okay, like let's see, what do I got selected here? And I have done something weird and wacky, and I don't know what. Yeah, unfortunately today is just one of those days where walking and talking. There we go. I accidentally rotated my root joint. Let's just triple check all of this jazz. I'm looking at the rotation values applied to the joint. Yeah, okay, great. Now we're back in action. Okay, so this is generally speaking what we want to have, bands of influence, okay? If you look at my hip joint, that's pretty good. Look at this knee joint. That's, well, kind of good, you know, minus the weird ankle bit there, okay? Let me just fix that real fast before we go any further. Let's see, I'm going to say right about in here. Doing a quick inspection, yeah, right about in here, I'm going to adjust weights, turn that off, okay, and then I'll start painting the weights in this ankle area, okay. So we want to have transitions in here. Put this to 80. Yeah, question? Yeah, go ahead.
Any tips on possibly like painting polygons that are not so easy to see?
Yeah, sir, you certainly could hide polygons. So if there's something like in there that's in between, two different, body parts or whatever, you certainly, you can use your traditional modeling tool set to go, okay, just hide those temporarily, and let's just check out what's going on, and just make sure you obviously unhide them. Yeah.
I'm having a weird problem.
Yeah. Yeah.
Soul of the shoe is separated from
Yeah,
that.
I'm having
Uh-oh.
the exact problem.
Serious issues.
One of the things that I do pretty regularly whenever I'm doing skin weighting is that I use my component selection system to get me going. The brush is kind of fun. The brush is really handy when you're trying to like smooth out the transitions between these different joints, okay? But if you just want to go in and assign values, let me tell you, selecting the components and then using adjust weights is a fast way of doing it, okay? Yeah, let's just see what that looks like. So when I rotate this thing, yeah, and rotate that thing, yeah, this is where I left off. Get lots of strange deformations. Yeah, that's fun. Okay, so this is a weight map bugaboo, right? These are the types of weight map problems that give you gray hairs, that make you want to pick up your keyboard and smash it against your computer for a couple hours, right? Because you're like, what is going on here, okay? I have maybe 1 or 2 verts on a different weight map that are set to 100%, okay? At times, we got to go in and do vertex level assignments here, okay? But luckily, this normalization process allows us to go pretty quickly, okay? Because now I can select just the verts that I think are the influence of this entire crazy problem. Yeah, something like that. And of course, adjust weights, 100%, boom. Problem solved. So if you have the sole of your shoe getting torn off, okay, start looking at other weight maps, okay? Yeah. I think the more that we strive to make this an organic process, the easier it will become. That's not to say it isn't frustrating, because it absolutely is frustrating at times, okay? I get that. Like, really, I do. Like the sole of the shoe. The sole of the shoe has this really weird, well, I think it's its own, well, no, yeah, it's got this really weird interior crease that's wreaking havoc on mine at the moment. Okay, just weights. Yeah, here's another weight map issue, right? There's a vert in there. It's that one right there that is not weighted correctly. On a different weight map, it's got some value associated with it. So another strategy, something you may want to think about as you go through this process, is you have to kind of make some decisions as to which joints are going to be like the primary deformers for that part of the mesh, okay? If you say, okay, the ankle joint is absolutely going to be controlling the back of the foot, and exclusively the ankle joint is going to be controlling this area, set all those to 100. Where it gets to be kind of tricky is at the transitions between the joints in the middle, okay? And sometimes just the process of selecting them, yeah, look at that. That's wacky and weird. There's a vert, probably right there. Yeah. So it can be annoying. Like this is driving me crazy. And let's see. So, as I mentioned to Mike, sometimes you just gotta hide things, get them out of the way. Yeah, there it is. It's way in there. On the inside, that little SOB right there, that guy. All my problems. I find the vert, yeah, problem solved. Okay. There's one more in there too that I gotta find. Maybe that one. Most likely not though. I'm inside the shoe now. Anywho. What? Oh, yeah, sorry. It was from 11 to 12 today. Sorry, Grant.
That's all right.
Yep.
Thanks.
All right. Let's adjust the weights real fast. Yeah, I didn't even get it on that one. It's still in there somewhere. I gotta find it. But we're getting better. Okay? Slowly we're building up the weight maps that we need to get the deformation that we're after. Okay? Luckily, the silver lining about this entire process of weighting, you only have to do it once, okay? It's kind of like UV mapping. Once it's done, okay? You want to give it its due process so that you can vary, so that it's perfect. You do it right the first time. I guess that's what I'm trying to say, right? That way you don't have to come back to it and live in the nightmare of making all this work, together harmoniously, okay? All right, questions, comments about weighting? Some new things, especially the idea of normalization. It's a big stumbling block for a lot of folks. So hopefully if you run into a weird weighting problem, start looking at other maps, okay? It's probably not the map that you're on. It's some other map that's causing the problem, okay? All right. Okie dokie. Oh, this also popped in during office hours this week. Question about the influence of the root joint. Okay, that's up to you. You got to figure that out. I know some character rigs where the root joint does not influence a single vert on the entire mesh itself. Okay, the influence is 0, and the hip joints are really responsible for obviously the deformation of the hip area itself. So that's kind of up to you to figure out how you want to work with the root joint. By putting it at 0, it shoves the responsibility to other joints inside of your skeleton to deform that part of your mesh. Just understand what your approach is, and make sure that the hip joints or the spine joints in that area are kind of taking the load of the weighting in that area. Yes?
Is there a way to see two of the weight maps at once?
Yeah, just have multiple bones selected.
Right, I tried that, but if I try to paint them...
Yeah, so you can't, I don't think you can paint on, that would be a cool feature though, right?
Because that way I can see where it is, like,
Yeah.
properly.
Yep, I totally get it. Totally get it. Yeah, that would be an awesome feature to have maybe like 2 weight maps simultaneously selected, and then to like hold down the control key or like, I don't know, some hotkey while you're painting, and that assigns the weight values to 1, and then hold on to the hotkey and it like load the weight maps into different slots, if you will. You can see both of them, but you're only painting on one or another. They don't have that. Yeah, in all honesty, I don't think I've ever seen any app have that. You know, if the Foundry developers are listening, cough, cough. That'd be an awesome feature.
It'd be really nice to be able to see where it is, so I can actually like, oh, this is where they're gonna interface. So I need to, like,
Well, we can see them, right? And you're seeing the blend between them, right?
sort of.
Yeah.
I mean, you can like switch between them, and then you're like, oh, this is the dividing line. But otherwise, I'm just kind of eyeballing it. So
Yep. I get it. Yeah. Yes.
More weirdness.
Okay.
A similar sort of thing, but I can't figure out where it's coming from.
All right. What's your weirdness?
This seems to work here, you know.
Yeah.
So the same. This is a little bit
Okay.
worse, but not as bad. But when I get up to here,
Uh-huh.
it really breaks.
I'm going to guess that those in there, the ones that aren't moving, don't have any influence on them at all. Because remember, when you select the parent, all the children are gonna move, right? If a vert doesn't have any influence across any of the joints, it's not gonna move at all.
Is there a way to select those easily?
go to the vert mode, blast it with, and assign it to the closest.
Yeah, that's a good workaround, because I think that's a. Let me see if I can. Let's go back to my little ankle thing here, since that's a real obvious geometric feature. Okay, so here's what I'm going to do. Say again?
How'd you do that loop selection out?
Hold down the shift key, hit the up arrow.
Up.
Yeah, it is a radial expansion of your selection. All right, so to prove, or not to prove, but to illustrate the idea that we're in here, okay, I'm going to go and I'm going to, on every joint, I'm going to set the weight values for those polygons to 0, okay? And I'm doing this intentionally, okay? Oops, what am I doing? Sorry. Yeah, I dropped my selection. Okay, 3, just weight 0. Now, if there is any influence on the toe, we have Serious problems. Okay. All right. So now, if I have in fact done this correct, my little ankle section here, that little knobby thing, doesn't have any influence at all. So if I was to move the parent, yeah, that portion stays where it is inside the scene itself. Okay. So if you're getting tearing like that, okay, that's a good indication that those polygons have zero influence across all the weight maps, and something we need to go in and kind of resolve. So you got to make some decisions. What ankle or what portion of the body does this most make sense to assign to?
Initially, when you bind it, though, it adds a value to everything.
Yeah, and by the definition of the weighting system, everything will get influenced. Okay. So usually these are problems and bugs that pop in after we spent an hour or so paint weighting. A vert here or there gets missed. Happens a lot, actually, on accident. I can't tell you how many times I've accidentally weighted something to 0 on accident. An errant selection, or maybe I had the vert on the back of the model selected and I wasn't aware of it. Yeah, it happens. So this is why you got to test it, right? The only way to be really confident and extraordinarily certain is to go in and test it out. Okay. All right, questions so far. Everyone's good? All right, excellent. Let's move on to the new stuff. And we're going to talk about inverse kinematics for a bit, and then we'll start going in and looking at how to do the reverse footlock and inserting some control points. Because the goal this week is to basically kind of round out and finish our rig, okay? With control locators and set-driven keys and the full shebang, so that we have a functional character rig that we can throw into animation, okay? Now, there are some challenges that are in front of us, and making a usable rig is at times kind of difficult. Relatively speaking, and this is going to sound crazy given the challenges that we're currently going through, relatively speaking, what we just accomplished is pretty easy, okay? It's pretty basic, okay? This is not an advanced rig in any sense. It doesn't have some good machinery on the inside that allows us to create predictable movements, okay? In the world of animation, there's two types of movements that animators are going to focus a lot of their energy on, okay? And these are actually scientifically crafted ideas, so this is not like according to Pat, right? But there's two types of movements out there. There are forward kinematic movements, and then there are inverse kinematic movements, okay? The arms and your legs are really great examples of both of those, okay? If you think about it, what type of movements do your arms do for the most part? Got a big shoulder joint here, okay? Your shoulder is a ball joint, okay? So you do circular movements, okay, and your shoulders. Circular movements like this, where it's just all rotation. I'm not moving my shoulder, I'm exclusively rotating it, right? If you take a step back and think about how our anatomy is put together, do we ever really move our shoulders? I mean, obviously, if we do this a little bit, right? Yeah. We move our arms, right? Our shoulders are, generally speaking, stationary, okay? They're connected to our spine. Where our spine moves, okay, we move the joints on our spine, our shoulders, and the plane that creates the tip of our shoulders, our shoulder line as it's referred to, stays pretty parallel, okay? Or pretty consistent the entire time. Obviously, this would be the exception to that, okay? Whenever we have movement like this, we create what's called forward kinematics, where it's just all rotation, okay? All rotation. Your wrists, another great example. All rotation, right? You don't actually move your wrists, okay? The movement of your wrist comes from your elbows, right? You move your elbows and your wrists move. But these in here are ball joints, okay? Or the illusion that we're crafting is something similar to that of a ball joint, rotation. Forward kinematics is kind of the default rotation parameter of every joint. What we've created on all of these joints so far are just exclusively forward kinematics, okay? Where rotation is the primary driver of the movement of the joints themselves. Now, that's not to say that we can't go in and move them. We can't, right? But when we start comparing it to the other types of movement, especially the movement that you'd see in your legs, right? When you're, doing this, okay? Are we rotating our knees up and down? No, not really. It's a little bit different, okay? We have this piston-like movement that we have with our legs often. That's called inverse kinematics, where you have the movement and placement of one joint being influenced by a third joint. This requires a chain, a triangle, if you will, of joints. Now for us, we want to start infusing these inverse kinematics in our legs, because the legs are a really, really great place to have inverse kinematics. Rotating both the hip, the knee, and then the ankle itself, just to have someone stand up and down, is kind of tough, right? And it's not the movement that we're going to get anyways, right? Our legs are kind of these pistons. They go up and down, and then we want a little bit of control on our knees so we can point the kneecaps where we want them to go. That's pretty much all the movement that our legs require. Going in and adding these inverse kinematics is really, really easy, okay? But it requires some intelligent selection. Now, luckily for us, we can do this at any point. You don't have to do this before we bind the skin, although that is definitely recommended, right? Having a really good, solid, complete skeleton before you bind it to the mesh is always encouraged, but we can absolutely go in and add these new elements after the skeleton is created, okay? Let's go in and look at the process that we need to go through to get all this up and running, okay? Now, I think I'm going to spend initially a couple moments here just cleaning up my item list and getting really super organized. Excuse me. Call this the root. Here are the hips, or hip. What is this? This is the left hip. I'm going to put L, hip. It's good to have a convention. L, knee. L, ankle. L, ball. And of course L, toe. Important distinction here. We have the ball of the foot and the toe of the foot, okay? What is not the ball of your foot? Interesting question, isn't it? A lot of folks, they think the ball of their foot, and what are they thinking? The heel. No, that's not the ball of the foot, right? What is the ball of your foot? Yeah, the kind of the patty looking thing, kind of right around the area where you have, I don't know what they're called, like your knuckles of your feet, of your toes. I don't know. Does anyone know what they're actually called? Yeah, I don't know what they're called, right? But that's the ball of your foot, kind of the middle of your foot, where this angle here, where your toes can stay flat and your ankle can rotate around. That's the ball of your foot, okay? Okay. So for me, it's represented by that guy in there. Okay, so now that we have this entire system in tow, we can start going in and adding this inverse kinematic system. Now we got to be careful in here. We got to be very, very careful with what we select in the order that we select it. Okay, and we're going to start generating a bunch of stuff. Okay, luckily the computer is going to handle the heavy lifting for us in the back end. But organizationally, we need to be aware of what the computer is going to be adding into our item list. This is where it gets complex, okay? So let's start off by looking at how we can infuse the inverse kinematic system into our existing skeleton. It's pretty neat. So if I grab the first thing that we're going to do, and I'm going to turn off the visibility of my weight maps now inside of my active meshes viewport properties. Okay, there we go. Dun, da, da, da. Now I'm going to grab the hip first, okay? So in every sense, we need to grab the topmost element in this cool little triangle that we're going to make, okay? Because we're going to get the knee to move for us automatically based on the inverse kinematic item. The next thing that we need to grab is the ankle. Now, very careful with your selection here. Go in. This is something that a lot of folks run into, accidentally selecting your mesh. Does anyone stumble on a way where I can turn this off? It's a good power user trick since we're talking about rigging. This is app. Because I don't want to be able to select my mesh. I'm actually kind of done with the whole mesh.
Assembly.
You could make it into assembly, but there's actually some easier ways of doing that. Just had a brain. Say again?
I said, can you just click it on the item list?
You can click it on the item list. That's fine. And some people like exclusively working in the list. That's cool. I like working in the viewport because I'm a visual dude, so I like being able to get in there and make some selections in the viewport.
Oh, I guess there's the possibility of like
And when you say the assembly item, do you mean the assembly tab? Because there's actually an assembly item which is a little bit different, but you're absolutely right. Yeah. Yeah. So if you go to the assembly tab, okay, see how under the selection section, you can say no. Now this is something that you have to manage and make sure that you remember that you turn off, because this will cause you to, again, pick up your keyboard and start whacking your iMac if you can't remember why you can't select your item, okay? But now, see, I can't even select my mesh item. That's pretty neat, okay? I've seen some rigs where they have on the actual master control locator itself, you know, that big ring that we made on previous rigs, okay? They'll have a little custom user channel that says selectable, okay? So it's just easy to, you know, toggle it on and off for animators that don't understand, you know, how you've created the rig. But for us, we'll just kind of do it like this for now. All right, so back to inverse kinematics, okay? So I got my hip joint selected, and now I'm going to blast down to my ankle joint and grab it, okay? Notice what's unselected in the middle. I did not select the knee in the center. I'm establishing the beginning and the end, okay? The middle is going to be taking care of us almost automatically for us. With those two in mind, let's return to setup mode so we can apply this new element of our rig, okay? We're influencing the bind, okay, we're influencing the raw skeleton. We're making change to an existing rig, so we got to be in setup mode to insert this stuff in, okay? With setup mode toggled, I now can travel over to my inverse kinematic series of tools. Inverse kinematics. And the first one, assign IK, all right? Assign IK, and before you walk away from this, the next thing that we need to do is assign a goal, and that's this big button down here at the bottom, okay? This is going to give us a control locator that we can manipulate and work with inside of the rig itself. So you assign the IK, and then you add a goal, okay? Bloop. Cool. And we'll start seeing the computer add a few things for us automatically inside of our rig. Let's exit setup mode, and I'm going to go in and grab the goal. Okay. Over in our item list, you can see that the computer is beginning to add some new things for us. We now have the solver inside the scene itself. That's this thing. This is kind of, if you want to look at it, think of this like as the brains of the entire operation. This is a whole series of, you know, formulas and mathematical, you know, garblegook, okay? That's driving the deformation in the movement of our skeleton chain. And this is the thing that we actually use to influence the skeleton, the goal itself. So I got my goal selected. And since I'm out of setup mode now, I can begin to move that. Oops, I forgot to weight that ankle bit. But you can see what the computer's doing. Cool, huh? And what this allows us to do, and that's fun, snap, ouch. Okay. Yeah. Now what this allows us to do is start animating our character a little bit easily, okay? Because I can rotate it around. I got to fix that weighting problem. That's driving me crazy. And we can start really beginning to work here, okay? Okay. This is how we start the conversation about our legs, okay? About animating our legs and giving our animators a system that allow us to very quickly get what we're after. Yeah?
How can we fix the knee bending inwards?
Yes, that's coming up next. Those are called pole vectors. Pole vectors, okay? And they're pretty easy to make, and we're going to talk about that next.
That's like on some of the models we've used before, it'll have the point right in front
of the knee, yeah. It basically creates what's called an up vector that says you are always going to be looking at this object, okay? Since the inverse kinematic chain is always going to be looking at that locator, we're not going to get that really weird whoop where the knee kind of spins around and pops around to the back of the rig, okay? So, what I'm talking about, just so everyone's on the same page, watch what happens to my knee. It completely bends the wrong direction. That's bad news bears for us, okay? And we'll get to a point where it does that. Now, I'm pretty sure that is anatomically impossible for our characters to do. It could be contortionist. I've seen, I love the Olympics, but I've seen some gymnasts do some crazy things out there, right? So I can't even touch my toes. I can't do that. Maybe someone in our world can. So we need to add a few more elements into the mix here that will allow us to get the deformation that we're after. So the next step, as Catherine pointed out, is getting the control of the knee, okay? Because this is a great system for us to go in and very quickly create that kind of pumping, piston-like movement for our legs, okay? But we need to be able to control it a little bit more directly, okay? Now I'm going to get this kind of back. There we go. Looking good. All right. And once again, let's go back into setup mode and start adding a few other elements in here, okay? Okay. Actually, you know what? Let's do this. I think now's probably a really good time for a break, okay? I've been going for about an hour and a half. Let's just take a quick break, and we'll talk about this after the break. Okie dokie. So before we went on break, we were talking about inverse kinematics, and we've done a pretty good job so far getting the system to work, but there's still, I think maybe the best way to put it is still some bugs in here that we need to smash, okay? So if I select the IK goal and begin to move it around, yeah, we're getting what we want, but clearly, yeah, we've broken our lovely guy's kneecap, and that's no fun. Woo! Okay, so we need to go in and start working with the kneecap itself, okay? Before we go too much further, though, I think this is a really good point to talk about the importance of resetting and zeroing out your transformations. I have my IK goal selected, and shoot, let's just give it a good name real fast. And I'm going to call this left IK goal. Oops. There we go. With it selected inside the three-dimensional scene, you can notice over here pretty quickly that we have transformations that are currently being active. Yes, sir? Say again? That's going to help. Yeah, that's going to help too. The location of the joint placement is going to determine the deformation of that area. But we still want to be able to control its relative angle, just like we can control kind of the rotation of our leg by changing, where our knee is situated inside the scene itself. So that's a step in the right direction, but it's not the complete solution to the problem itself. All right, so back to our transformations here. If you look at what the IK goal is currently reading, man, there's a whole bunch of position and rotation information inserted into that item itself. When we're animating, or excuse me, when we're rigging, we always want to give our animators the opportunity to kind of like reset the rig, put the rig back to its, or put an item back to its kind of bind pose position, okay? So we need to infuse that into the scene, or into the rig itself. I want my animators to be able to go in, select this joint, and put 0 on every single one of those channels, except for scale. So for position or rotation, I want it to say 0, 0, 0 for XYZ on position, and the same for rotation, okay? That gives them kind of a default pose, the original bind pose. We're resetting the location of this so that if I mess up, or if I want to go back and change something, I can easily do it, right? Luckily, this is pretty easy, okay? And we do this not in the reset button, because if we reset our transformations, like for example, I'm going to reset position here. Watch what happens whoop, to my rig. Where's it go? If you turn the grid back on, you'll probably see pretty quickly that when we reset our transformations, it goes back to the origin, right? I want that location right there to be the origin. Okay, or hold on a sec. There we go. I want that location. Wait. There we go. I think this current location. Yeah, I want that position right there to be like its new origin, if you will. Okay. I want this location of my IK goal to be like its new home, right? When we reset our transformations, I want my IK goal to go back here, not to the global origin of our three-dimensional scene, okay? So the way we do this isn't by resetting it, because the reset function is basically going to return zeros to all of the channels in the selection that we choose down here. What I want to do is 0, okay, our transformations. So I'm going to choose to 0 out the position. And again, watch what happens to my IK goal in my rig. Bloop, what happened? Not a single thing, okay? If I 0 out my position values, same thing. Doesn't go anywhere. Now if I make a change to the location of my IK goal, I can get it back to its original location by returning 0 to the item transform section, okay? It kind of like resets the pose and resets the rig back to its local kind of position and understanding of its original location inside the scene itself, okay? This zeroing process is going to be important going forward, okay? All right, now that we've zeroed out the location of our IK goal, we need to start going in and adding a few more elements to get that pole vector, as it's called, that knee control really in line here. And since I hit undo a couple times, my naming convention got removed, so bear with me just for 1 second. Left IK goal, awesome. All right, So now what we need to do is that we need to add a few new locators into our scene, and this is where the complexities of our rig kind of just bounds to the surface. If you've already looked at the learning resources that I gave you guys in Canvas, let's just travel back to it. Okay, I'm basically reading this part now. Okay, oops. So just keep that in mind. If you get lost or you get, add a sequence here, I'm in the creating the knee up vector section in the instructions that I provided you guys. Okay, so let's go back into Modo and start laying all this stuff out, because we need to start adding a few new locators into the scene. These are utility locators that will help us create a series of constraints and up vectors for us. Okay, because we need some additional information. So we're going to add a new locator into the scene. Bloop. There it is. Okay, this new locator is going to be called root leg left. Okay, and this is going to become the new parent of the entire leg chain, not the entire hierarchy, right? It's still going to be a child of the global root locator for our rig, but it's going to become, in a moment here, the new controller of our leg. Okay? Now I need to get this thing into position pretty quickly here. So luckily for us, our drop actions are going to allow us to interactively place this locator where we want it to be. Okay? And so I'm going to choose match position, because I need it to be in the exact same, and I mean the identical place of our hip skeletal joint. Okay? So I want to drag and drop my locator on top of my bone, bloop, and it goes right up there. FYI, I was talking with Alan, I think, about this during the break. It's much, much easier to work with the bones versus the joints, okay? If you think about it, I'm just hit undo. I've gone back one stage, okay? Going in here and selecting one of those small, thin kind of, wireframes for the joint at times is really difficult, right? Because you have to be almost like pixel perfect in your selection accuracy, right? A much better way, well, not a better way, but an easier way for me and my old eyes is to work on the bone itself. If you click on the bone, I can click anywhere inside this cool trapezoid thing and select the actual joint itself. It just makes selecting and working with these joints a little bit easier. Sidesteps having to perfectly click on that very thin joint wireframe. All right, let's go back to match position in my drop action. And on my locator, I'm just going to drag and drop it on top of my hip bone. And you can see where that locator goes, right up there. Now, I need to have the computer consider its current location as its home location. So what do I need to do? Zero it out. Right, I got to zero out the transforms. In this particular situation, zero out the position transform channels for my new locator. Zero position, and we're on our way. Okay, now we need to do basically this exact same thing again, but this time we're going to create a new locator for the knee. Okay, so I'll create a new locator. Now this one, what I'm going to call, as one might imagine, this is the left knee control. Okay, and when we're done with this entire sequence, this one locator is going to be responsible for directing the knee where it's going to go inside of our three-dimensional scene. So it's an important one for us. And like we did for the root leg left locator, I want to drag and drop this knee locator in front or on my knee. But then I'm going to move it kind of out in front a little bit. Now, don't go crazy with this, okay? A lot of folks are like, oh, I'm going to put it like way over there. No, generally keep it close to the body. We don't want it right in front of the knee, but we don't want it so far out away from the knee that we lose a good understanding of its function, right? Because remember, you're not going to be the one that's animating this rig, right? An animator is going to be animating this rig, and we need to make it very clear as to the purpose of these locators in the scene itself. Now, right about there is pretty good, and since I'm me, I'm going to go in and make a custom shape. I like this for my knee, my pole vectors. Let's see, I want to use, I don't want a box. I want to have, let's do, oh, they added one in here called point. I didn't know that. let's do pyramid. There we go. And it's way too big. So I want to change its size values down quite significantly. Something like that. Okay. Now I also like to color big control points like this. Okay. You'll see this a little bit later on when we start working with the green guy. Yes, ma'am.
Can I see yours from the top? Just curious if you're located at the top.
Yeah, mine if for the knee. Yeah, no, mine's, if you look at it from the side, that's kind of right where it is. Let's see, from the top, mine's perfectly in line. The foot's angled off. Yeah, we may be getting a little bit of an optical illusion. Yep. All right. One of the things that's helpful, especially with having an animator or just someone on your team understand the purpose and the assignment of all these control locators, is to color code them, right? What color is our IK goal at the bottom of our ankle? Green, yeah. Left is usually green. Right is usually red. Central control points that do like the spine or the head are often yellow. Those are conventions that you see all the time out there in the real world. So I'm going to continue to apply those to my scene. And let's just do it real fast. So we'll go into display. I'll add me some draw options, and I'm going to change the fill color to a user-defined fill color of a lovely shade of green. I'll do the same thing for the wireframe color. Bloop. I'll make it darker. I like my wireframes a little dark, but that's just me. Aha, wonderful. All right. Now that I've gotten real fancy with my display properties, let's also zero out the positions of our new knee control locator. Right about there. All right. Okay, so now what we got to do is that we have to start putting some directional constraints in the system itself. Okay. If you think about it, we have an entire chain of skeletal joints going down our leg, right? And at the top of that chain, we have the hip, which is always looking at this IK goal, right? The hip joint itself, the hip skeletal joint is always looking at this IK goal, right? Well, to get the knee to work correctly, that new root leg locator that we created has to be kind of a member, if you will, of this entire IK system. So here's what we're going to do. We're going to create a directional constraint between the IK goal and that new root leg locator that we were working with just a second ago. Okay? All right, so we're going to start with the root locator, which is that guy. Now I'm going to hold down the control, mouse selected. Hold down the control key, and I'm going to either very carefully select the IK goal, or if you wanted to do it over in the item list, 6 to 1, half a dozen to another. Okay? We are constraining, or we're making a directional constraint between the top, the new top of this root or this leg hierarchy, and the goal itself. With those two things selected, we can return to our modifier section, and we're going to apply a directional constraint. Now, the directional constraint is really important for us because the directional constraint is where we're going to be able to add our knee locator as what's called an up vector. Okay? And you'll see this in action here in a second. So that's why we create these directional constraints, so we can create an up vector. Oops. Select the, what did I miss? I messed up here something. Did I skip a step? Oh. I say control. I think I needed to hold down a shift. There we go. I said control earlier, and it's supposed to be the shift key. All right. Aha. Awesome, huh? If you look very carefully, I'm going to turn off the visibility of my mesh. See that little blue line? That line right there? That's a visualization of the directional constraint, okay? If you think about it, now this leg, or this root leg locator at the top of our hierarchy, visually at the top of our hierarchy, is always going to be pointing towards the IK goal, okay? Now, I want that point to be influenced by the location of this pyramid out here in the front, okay? So in order to get this to work, I got to go into the actual there we go. I got to go into the actual directional constraint now, okay? And we need to start applying this new locator as the up vector. So please note, I have the directional constraint selected because we're influencing a property on the directional constraint. I'll hold down the shift key, grab my knee locator, and now, over here, assign up vector has been kind of highlighted for us instead of our modifier section. Bloop. That dotted line is a representation that it's mission accomplished. Can you guys see that dotted line? So if you get that dotted line, mission accomplished. All right? Now what this is going to allow us to do when we're done, and we're not quite done yet, okay? So we can move this, all right? But now, we haven't, not quite finished yet because we haven't parented everything in there. But you can see at the top, see how the locator is rotating? The locator is now using this location of my little pyramid guy to develop, to determine kind of its understanding of the direction it's supposed to point. Excuse me. Okay. So now what we need to do, this is where it gets fun. We get some item list stuff that we need to do. Okay. We are going to take this entire hierarchy, and I best do this in setup mode before my entire world breaks apart. So here's the entire leg hierarchy. I need to get this thing in there. Does anyone remember how to do this? Yeah, we've done this a couple times before. There are about a half a dozen ways to get that new locator inside of an existing hierarchy. So let's give that a try. Make it a child, right? Of the root. And then we can reassign. That works. Okay. If you look carefully what I did here, I made the root leg left a child of the root joint itself. Then I took left hip and dragged it on top of root leg left to reassign that entire hierarchy underneath my guy. Okay, that works. Let me hit undo here for a second. Go back in time a couple steps. There we go. Okay. Another way you can do this, of course, use our drop actions. You can do insert. Okay. This will insert the selected item inside a hierarchy. Okay. Oops, I didn't select it. So now we've got to be careful here. Got to insert. I'm going to drag it on top of the root joint. Oops, that made it the parent. I grabbed the wrong one. Sorry. I drag it on top of the, there it is, of the hip bone itself. 6 to 1, half a dozen to another. You get the same thing either way. Yes, ma'am. Yeah, so it's going to twist a little bit. Okay. How weird is weird? I think mine even twisted a little bit. Pretty intense. Pretty weird. Okay. Hang tight just for 1 second because the next step may resolve that twist. Okay. All right. Insert this thing here real fast. I hit undo. There we go. I like the insert because I'm a drag and dropper. I really like using the viewport to get what I'm after. Oh yeah, that's fun, isn't it? Yeah, and I think I actually know why I'm getting the twist. I don't believe I zero. Look at that down there. Now that we have a more complex system in here, we should have zeroed out all of the joints, position and rotation values before we started this. But we're going to do this again here in a minute, so we'll get there. Yeah.
You're also not in setup?
Not anymore. Yeah, in setup mode it works fine. Yeah. But when I go out of setup, then all those twists happen because there are transformations on the joints themselves. And this looks like it's probably that one. See if I zero out these rotations. Yeah, it gets worse. Okay. Yeah, we'll resolve that in the next step. Yeah, it depends on how you made your rig. Let's see. Yeah, I'm pretty sure it's the main culprit here is that. Yeah, we forgot to zero out the rotation of our joints. Okay. Anyways, let's finish this and we'll get back into it. Okay. Okay. So now that we've parented the everything to the new locator up at the top. Okay, let's make sure that we zeroed out this guy. Yep. Now we're going to parent. Well, we're missing a step here, but it should work. Let's test it. Yeah, wonderful. Yeah, this is what we're after. Yep. It's just backwards at the moment. But it is working. It is working. Okay. One of the things that we can do, let's see. Sometimes doing the negative axis on the directional constraint, we'll flip it around correctly. In this case, the spin's gone, but we're still getting, now my leg's bending backwards a little too much. Yeah. And because I didn't rotate, yeah, that's what we're after, just everything's backwards. And it has everything to do with the fact that I forgot to zero out my bones earlier. Crazy, huh? All right. So that's what we're after. That's how you do it. Let's actually make it right. Let's actually fix the problem here. And this is one of the steps that a lot of folks just generally don't want to do. Okay. I could fix this, right? There's a lot of fracture points in my rig. Okay. I could go in and I could spend a lot of energy making this right. Okay. Or I can just re-rig it real fast. And that's what I'm going to do, okay? You know, this is one of those parts that no one wants to do, right? It's just kind of start over real fast, but you know how to do it, okay? The first time is always the hardest. The second time is a little bit better. The third time, and you're going to do this for your homework, it's going to be a little bit easier, okay? So here's what I'm going to do. I'm just going to redo this so that I can get my transformation kind of dialed before I bind stuff. So I'm going to revert my project file back to its original, and we're going to do this again, okay? We're going to go through the sequence again, okay? All right, so first things first, let's get a skeleton in here real fast, and I'm not going to forget this time to zero out the transformations of my skeletal joints. And luckily, I'm not going to have to go in, I'm not going to spend a lot of time on the paint weights. They'll be a little wild and wacky, but that's okay. There we go. Awesome. So if you look at the transformations of all of this, yeah, see how they have transform information placed in here? Position on the root, on this guy, position, lots of position. I want to zero out the transformations on all of these before I go any further. Zero out position, zero out rotation, make sure they're nice and dialed. Yeah, and if you get weird twists like this, it's a good time to spot check your rotation. You just got to have one axis that's shooting down the chain, okay? See how I have one axis, the y-axis, and this one runs down the bone itself? Use your tool handles to do a real good kind of analysis of the type of transformations you're getting. Yeah, generally speaking for mine, the y is getting me what I want. Here it's the X. It doesn't matter if it's the same one. It just has to work. There we go. Okay, I'm real happy with that. Let's bind this bad boy real fast. Hey, how about that? That didn't work for me. It really does not, oh wait, turned off the visibility of my weight maps. I was expecting to see, there we go, it works. So I got some problems in here, but that's okay. Some weighting problems that I'll resolve at some point, but generally speaking, this is working, okay? Pleased with that. And specifically, this is why it's so important to do the zeroing out, is that I now can go back to each one of these joints, reset its rotation values back to 0, and they're going to go back to this bind pose. Cool. All right. How do I add the IK handles? hip, ankle. Okay. Do all this in setup mode, by the way. Okay. And then we'll go into the inverse kinematics section, assign IK, and then immediately assign the goal. Okay. Let's exit the setup, test it out real fast. If I go up on this, yeah, there it is. That's what I'm after. Okay, rock and roll. That's working pretty well. Okay. Let's zero out some stuff to make sure that we're getting exactly what we're after. Okay. Let's zero out the position and the rotation channels for the IK goal, and also, while we're in that area, zero out position, zero out rotation. Okay. While we're on that item, let's give it a good name. This will be left IK goal. There we go.
So zero out everything?
Basically zero out everything, yeah. Question?
So the joints, the goals.
The joints, the goals, the locators that are going to be responsible for controlling the rig. Those are generally the things you want to zero out. Yep. Okay.
Anything you don't want to zero out?
Say again?
Is there anything you don't want to zero out?
Yeah, there's a couple joints in there that you're not going to want to zero out. A couple constraints as well. In a second, we're going to talk about the reverse footlock mechanism that we're going to build. There's some things in there that you don't want to zero out. The kind of general rule is that if it's responsible for deforming the mesh, probably zero it out. It's a good place to begin. If it's a subcomponent of a much larger architecture, you probably are not going to have to zero it out. If it's something, if it's a locator or a joint that you know your animator is going to touch and going to deform and move around, zeroing out ensures that it goes back to its original bind pose. All right, so proof of concept. I'm out of setup mode. Let's grab the joint. Oops, didn't mean to rotate it. There it is. Excelente. It is deforming the way I want it to. But now let's get that knee control in there real fast. Okay, so let's add some locators. As we explored a moment ago, this is going to be the new root of my left leg. So not riot, root, leg, left. Or actually, let me follow my convention. I had a little dyslexic moment there. Root left leg. Okay. Where's this locator going to go? Where are we going to position it? At the hips, right? Because we want this to be the new controller of the entire leg. This is required for my directional constraint to work. So I'm going to change my drop actions to match position. That way I can just drag and drop it on top of the joint. And it's going to go where I want it to go. Whoop, there it is. Let's zero it out. Looks like it's just going to be, oops, do I not have it selected? Zero out position. There we go. And let's do the exact same thing for our knee. Let's add one in. Call this left knee control. Yahtzee. We'll drag and drop it on top of our knee, but where are we going to place it? Because the map position just kind of gets us close. Where is its actual home in our 3D space going to reside? In front of it. Yeah, in front of it. If it's actually on the joint, that causes massive problems for us. Okay? Somewhere right around there. I'll make it pretty here in a second. Its default locators are fine for what we're doing. Okay? Okay, now what do we have to do? What's the next step? The directional constraint, right? So we're going to constrain the root leg left, okay? To what? Does anyone remember? The goal, right, yeah, because we want the new locator at the top to always be pointing at the IK goal. So we'll add the constraint into the modifier section, directional constraint, boink, get that little line in there. Aha, that's what we're after, right? And now, and here's the kind of the cool thing. We have to do the up vector next, right? But if you look at what the product of this operation gives us, okay, it gives us the correct selection already. So what you could do, because my directional constraint's right there, you can actually select it, or the locator itself, 6 to 1, half a dozen to another. But we'll hold down the control key, grab my knee control, and assign the up vector. Okay? Yeah, go ahead.
Is there a way
Which text?
On the item list?
I wish there was, yeah. I can't tell you, I have, on these iMacs, I can't tell you that even in my office, I have to zoom in on the text to make it actually readable at times. Yeah, this is a problem that all software is running into. The resolution of our screens is getting so intense, but then the text is staying the exact same size, right? On these 4K monitors, all the text is like teeny tiny small. Yeah, I hear it. Especially on a pair of old eyes like me, I want all the text to be bigger. All right, so my knee control locator isn't doing anything yet, really. You know, I can move it around, but I need to insert my root leg left into my skeletal hierarchy. Okay, there's the hips right there. So let's do it real fast. Okay, let's get it in there. Excuse me. And I'm going to change my drop action back to insert. And I'm going to left click and drag on my new root leg left locator and insert into my hierarchy. That's fun, isn't it? Yeah, that's pretty not what I wanted. However, let's test the system. Now I was doing this not in setup mode, which is maybe our culprit. Yeah, that's fun. Let's go back in time a couple steps. I exited setup mode. And let's try this again. Okay. Go. Exit setup. There it is. Yeah. It was because I wasn't in setup mode when I did that operation, and everything spun around and you know, kind of got distorted pretty quickly. Now, if you look at what we've created here, I can grab that knee locator and watch what happens to my knee. See how I'm just influencing it individually from the chain itself? If I grab the goal and move it up, now I can grab the knee locator second and change the angle of my knee. Cool, huh? And that's how you make it. Yours still goes backwards? Yeah. Are you in setup mode? No, yeah, go in setup mode, yeah. Basically, here's the good rule of thought. The school of thought. Huh?
I did it within setup mode. I just went out of setup mode.
And it twisted?
Yeah.
Here's probably the school of thought that I would recommend. Do all of this in setup mode first, okay? And when you finish the sequence, exit setup mode and see how you've done, okay? That ensures that these new additions to your rig aren't receiving any sort of transformation that you've accidentally applied outside of setup mode. And like I did, and this is, like I said, this is the part that no one wants to hear, sometimes the best thing is to redo the rig real fast, you know, to go through the sequence. In all honesty, I'll be honest with you, whenever I rig a character, I always have like 4 different kind of milestones of the rig itself, just in case something explodes in front of me and I go, oh, why is this happening, right? I can go back to the previous version. Like I have a skeleton version of my rig, right, where it's just the skeleton, not bound to the mesh at all, right? And then I have another version where everything's bound and all the paint weights is done. And then I have another version where all the control, you know, the control locator stuff is inserted. So that way, and then I have what I have. This is kind of an old school way of thinking. Is what's called a gold master candidate, a GMC version of the rig. Okay, and that gold master is the one that we actually send to the animators, the production rig that our folks are going to be using. So, yeah, save your 2 a.m. sanity by pumping out, you know, kind of milestones of the rigging process in case you have to go back, you don't have to completely start over. Neato, huh? All right, let's get my stuff back here. And I'm pretty pleased with what I've created so far. Now, I was a bad steward of my rig, and since I restarted, I didn't have a chance to rename my joints. So let me just rename them real fast. Here's root leg left. That was the new one I added. This is left hip. This is left knee. And I really can't recommend enough naming things as you go, because as you can see, I mean, skeleton, spine, O2, what? You know, the list, believe it or not, the item list is going to be your friend, okay? However, got to name things. Keep your sanity. So this is left ankle, left toe, not left toe, left ball, excuse me. The ball of the foot and then the toe of the foot. Left toe. There we go. That's a little bit easier to understand. And yes, I'm going to make it pretty because I like my pretty shapes. Some folks, well, I was going to say some folks like to flip that little triangle thing around. Oops, let's reset the position of that. Ooh, I never zeroed out the transformations. Ooh, oops. Bad, Pat. Let's zero out the position information. I'll zero it out there. Now we're back in action. Oh, one other thing. If you work with these custom shapes often, as I do, sometimes it's really critical and very important to understand the location of the local center point for that item. But once it's done and rigged, it's just visual noise. You know, you don't need to see the center point. That's one of the parameters that you can turn off. I do it all the time. Okay. So you can do under the style, do add. Oh, I'm sorry. I'm in the wrong place. It's under display. Excuse me. And the center point's visibility, I'm going to put the no. That way, when it's not selected, I don't see it. Let's give it a pretty color. I like my colors too. Make it a nice dark green for the wireframes, and the fill color, I'll make a nice light green. There we go. All right. Now we're talking. As I mentioned before, you know, really use those instructions that I provided you. That sequential list is going to be a saver. Okay. Okay, we can figure it out. I don't know without. Oh yeah, that is fun, isn't it? Yeah. It could be. Where's the location of your knee joint in reference to? Yeah. Try putting it in the front. See what you get. Okay. Yeah, so use that list, that handout that I gave you. That's going to save your bacon 9 times out of 10, okay? In addition, one other thing that I would recommend that we spend some time working on today is getting the foot to work correctly, because we really don't have any controls on the foot, okay? Now, the foot can be dangerous, because if you think about it, we have a whole series of joints that are going down the center here, okay? And the ankle one, that's going to kind of take care of itself for the most part. But the ones that get dangerous pretty fast, believe it or not, are the ball and its relative location inside of 3D space to the toe. Without some control in here, it's going to flip over, which we don't want it to do. And you get this really odd kind of, looks cool, but doesn't look real, right? This really kind of vortexy twist thing. In addition, so we want to avoid that. In addition, we also want to try to get some heel control as well, right? Because if you think about it, as an animator, the animator is really going to have 3 points of rotation that they're interested in doing, right? They want to be able to do this, to raise the heel but not raise the ball and the toe. They want to be able to do this, where the foot is flat, so the rotation happens exclusively around the toe. But then, inversely, they also want to be able to do this, whoop, right? So the 3 ranges of motion we need to establish. Right now, we don't have any control over any of those, right? So time to go put it in. This is called the reverse foot lock, and it's about as industry standard of a rig as we can get. This is probably the one part that you're almost guaranteed to see in every single rig, okay? Because it gives us those 3 kind of rotation zones that we're after easily. As one might imagine, though, we need a bunch of locators in here to start getting what we're after, okay? So let's do it real fast. We're going to create 4 locators just right off the bat, okay? And this is absolutely one of those things where naming conventions is going to help, okay? So let's do it. I'm going to create 4 locators. The first one, I'm going to dial in the size because it's a little too big. When you're changing the size of a locator, Don't change its scale values. This is bad juju, okay? This is going to mess things up in the big scheme of things, right? If you just want to change its visibility, go into the display properties of a locator, or any item for that matter. But specifically on a locator, we have this size option, okay? This is the best way to make sure that our locator just visually looks smaller. Since we're going to have 4 of them in a relatively small area, making this smaller is probably a good idea. All right. Let's start naming things. All right, so we're going to have ankle control, heel control, ankle control. Here, let's be, sorry, I got ahead of myself. This is left ankle control. Does anyone know, off the top of their heads, the keyboard shortcut to do item level duplication? Does anyone know? This is a power user keyboard shortcut. It's Control D. D is in duplicate. Duplicate. You have to be in item mode. Control D makes a copy of it. Okay, that's kind of handy. Okay, especially if you've changed the display properties of an item. All right, so this is left heel control. Control D. The next one's going to be left ball control. And the last one, of course, is going to be left toe control. Okay. Now we need to get, now that we've created them, we got to get them into position here. Okay. This is where our drop actions make this entire sequence go a whole lot faster. Check it out. Okay. Drop action, we're going to do match position. And now I'm going to drag, oops, grabbed the wrong one, ankle. Ankle is going to go on the ankle joint. There it goes. Heel, this is a little bit odd, okay? The heel one is going to, we're going to drop it in front of the ankle, but then we're going to bring it down and back. So it's just going to be kind of close. Then we'll bring it down and back. This actually needs to be kind of right around there. Okay?
In the mesh or out the mesh?
I put it outside the mesh a little bit. Basically what you're defining is the point of rotation inside of your three-dimensional space. That's a good spot for it. You know, you could put it a little bit further back and that'd be all right. Ball control, as one might imagine, is going to go right on the ball of the foot. And toe control is going to go on the toe. All right. Since these are going to be major influencers to our rig, let's zero out the transformations on all of them.
You say ankle control should go on the ankle?
Ankle goes on ankle, and then the heel, I dropped it on the ankle, but then I moved it kind of where I want it to go.
Oh, there it is. Weird.
I reverted the whole project now, but I assigned it IK to it. Oh wait, now it decided to have to go.
Yep.
Now, for some reason, this one wouldn't appear.
Cool.
But now it just
Yep. Exit setup mode real fast and see if it works. Aha! Mission accomplished. All right, let me catch up with you guys. I want to zero out my position on all four of them. Yes?
Is there a reason why that locator that's next to it has to be within tip? Because I forgot to put it in and it works when I don't put it in.
Eventually, it's going to need to get in there.
Okay.
Yeah.
So it has to.
It has to be in there. Eventually, it's going to need to get in there.
It'll just become like it's working.
Yeah. Okay. You could, yeah. It's just get it spatially where it makes sense. I think I could definitely, if you look at where mine is, yeah, I could definitely move mine around a little bit. Here, let's just do that. No, don't mess with the rotation yet. Yeah. My dork accidentally hit 0 instead of, or accidentally hit reset instead of 0. Go. Alrighty, right. Okay, so now it's time to start making a hierarchy so that all 4 of these locators work in tandem with each other and with the IK goal, right? Because we're creating a whole kind of little miniature system down here in the foot itself. And one of the reasons why it's called a reverse footlock is that we parent all of these locators in reverse, right? So the ankle gets parented to the ball. The ball gets parented to the toe, and then the toe comes back and gets parented to the heel, okay? Now, the best way to do this is to change your drop actions to parent in place, okay? That way they don't move. We'll go into setup mode. I was out of setup mode. Bad Pat. So I want to very carefully grab. Oops. When I reverted, I forgot to turn my selection assemblies values back to no. I don't want to select the mesh. Okay, there we go. That makes it easy. So now, parent in place. I want to drag on top. Yeah, so I got the ankle control locator, and I'm parenting it to the ball control locator. The ball gets parented to the toe control locator, and then finally the toe locator gets parented back to the heel. Oops, and I don't believe I did that. There we go. So in essence, this is the structure that we're looking to get at the end of this process. Heel, toe, ball, ankle. Okay? Really what we're after here is that we want to be able to move the heel. See how when I rotate the heel, the other 3 move in tandem? That allows us to do this with our foot, right? Okay? This hierarchy also allows us to go in, grab the middle, and start doing this. I know it's kind of hard to see with just locators, but I grab the ball, rotate it, the ankle goes where it needs to go, and the toe stays stationary. And then finally, if I grab the toe and rotate it forward, you can see where we're going. Okay. All right. Now we need to go in and start making some constraints, because I want certain bones inside the foot area to be constrained to certain locators. Okay? The first one up is the ball. So I'm going to select the ball bone first, because I want to constrain it to the ball control locator. Okay? Select the joint first, locator second. The modifiers tab will assign the position constraint. Now when I select the locator and move it around, that joint also goes along for the ride, which is what I'm after. So we constrain the joint to the locator. Okay? The position constraint. Now, this kind of goes without saying, but I want to make sure that the ball joint itself is always pointing at the toe locator, right? Makes sense. That way we don't get any sort of weird kind of twists in between. You know, that would be bad, right? You know, kind of some sort of lateral twist in between. You know, I don't think I've ever seen anyone's foot in between the ball and the toe do that. Maybe in an extreme cartoon situation, but we don't want to have that generally speaking. So what we're going to select the ball joint first, the toe locator second, and apply directional constraint. That way, whenever I move the toe locator, oops, I hit the wrong key. Yeah, it works together. Okay, that's what we're after. Now, okay, with that kind of system in place, we can start incorporating the rest of our rig, okay? So this next part is about taking that IK goal and inserting it into this small little hierarchy that we've created with these locators, okay? So it's real easy. I'm going to do a parent in place, okay? And I'm going to parent the left IK goal to the ankle locator. So way down over here, drag, I'm going to drop it right on the locator, bloop, and it parents it in, which is what I want. So now when I grab that ankle locator, it's going to move in turn that. Okay? Now we still have some work in here to do, so we're not done yet, which is why the rest of the foot isn't working. Okay? But that's working the way I want it to work, which is kind of cool. Okay, so what the question was, what's this supposed to look like when you parent your IK goal to the ankle? Just like that. So really the IK goal is going to become a child of our ankle joint. Yeah.
I just wasn't noticing.
Yeah, here's a good kind of solid confirmation that things are working the way that they should be working. If you grab the heel, because remember the heel is the parent of this entire foot mini hierarchy, right? If you raise it up, now look what goes along for the ride. Cool, right? Once that IK goal gets in there a little bit, we can start, crafting something that's kind of fun. All right. So the directional, yeah, go ahead. Okay. It's kind of hard for me to know at what point in the sequence you're in. Make sure you're in setup mode, though, right? Okay. Do you have that top hip joint selected? Great. Select your ankle joint. Have you already applied the inverse kinematic solver to your skeleton? So did you hit add IK? Oh, we're in a very different place, I think. Yeah. Why don't you just hang tight for a couple minutes, Liam, all right? Okay. We'll get you up and running. Okay. So if you kind of go back a little bit and think about what we accomplished earlier, we did a directional constraint between the ball joint and the toe locator, right? That kind of guarantees that the toe is always going to be in line. We're not going to get any sort of weird twists as if all your toes have been broken. That'd be painful, okay? Especially when we have like a rigid boot like this, we're not going to get any sort of kind of deformation of the boot going like that, right? However, there's nothing that's inside of the rig that's going to basically limit this section in here, that joint, from going flip like that, okay? Especially if we have it rotated back, the whole foot, the whole thing could just twist for us automatically, which we don't want to have happen, right? we don't want to have kind of this vortex spinning down our chain. So we're going to create another up vector, kind of like what we did for the knee, right? Now to create this up vector, first we have to start with a locator, so let's do that real fast. Add a new locator. Of course, we're going to give it a good name. I'm going to call this left foot, left foot up vector. There we go. And let's get it into position. And this is where I love my match position, right? I want to match this locator's relative position to my ball joint. So let's drag it on top of the bone. And I want to place it above the foot. Okay? Doesn't really matter where, but it's just, it can even be inside the mesh. I think out of habit, I always put it outside the mesh so I can see it a little bit easier, excuse me. There we go. There's your blows. There it is. All right. Okay, so now what we need to do is that we need to go into the directional constraint that's on the ball joint itself. Okay, there it is. Now, there's a couple ways you can do this inside of Modo. If you go into the item list, you can find the actual item that contains the constraint. Click on it. There it is, directional constraint, left toe control. Another way you can do this, it's a little bit more difficult, but you got to kind of understand what you're looking for, is you can just go to the very tippy top of your scene hierarchy. There's a little plus sign next to your scene name. That's going to show you all the constraints that are currently active, and there's the one that we want to work with. Okay? So just select it one way or another. There's a couple different ways of getting to that end result. And then, like we did earlier with the knee, I'll hold down the control key and grab my up vector, or my locator that's going to be transformed into the up vector, which allows us to assign it as one over inside of our modifiers toolbar. Bloop. That dotted line appears. Now we need to get this up vector into our hierarchy. So I want to parent and place the foot left up vector to the toe, okay? That way, where's my mouse cursor? There it is, great. So now let's do parent and place in our drop actions. And I'll left click and drag my left foot up vector onto my toe control. And believe it or not, folks, that's it. That's the end of the game. Let's test it, okay? Proof's always in the pudding. Go out of setup mode. And looks like I forgot to reset a transformation along the way. However, it does work. Yep. Oddly at the moment, but it does in fact work.
Does the left heel control need a directional constraint as well, or sorry, a position constraint?
No.
No.
No. Yep.
I'm moving the heel and it's not doing anything, but if I rotate it, it affects the mesh.
Okay, let's see what's going on here. Did I miss something? No.
What are we supposed to click with the directional constraint? It's the toe control and then what's the other one?
So what point are you in? What are you?
Doing this last part.
So you're doing the up vector for the foot?
Yes.
Yeah. Okay, great. So yeah, so you got to have the directional constraint that's on the ball, and then you shift click the locator above the foot, the one that's going to serve as the up vector.
Directional constraint for the ball here.
Yep.
And then the directional one. And then
Yep.
what was the other one?
And then would be probably that yellow one. Yep.
Okay. And then I guess the vector.
There it is. Cool. Now I think the step that I missed in here and why I was going all wacky was that I forgot to reset the transformation or zero out the transformations of my IK goal because it has a whole bunch of rotation and position information being sent into it. So let's zero position, I'll zero rotation. And hopefully now, no, something else is influencing it and I don't know what. I'll have to figure that out. Yeah, something's going on. Got to figure out. Welcome to rigging, right? You create one thing and then three things get broken along the way.
So what would you use to control the foot, the heel?
The heel. Yeah, the heel now becomes the driver of this entire operation, right? Because it all comes down to the heel. Because we want to, this is the idea that we're after. Okay. We want to be able to do that. Okay. We want to be able to go in and grab the toe. Also rotate it up like that. Yeah. The heel is now the primary driver of this entire thing. I move the heel up, the entire rig goes up. Yeah, and then I'm getting some double transforms in here, which is stretching everything out. Something, let's see if I can figure it out. What is it? Is the joint? It shouldn't be the joint. And what issue is that?
Oh, the same things, almost exactly what's the same as yours.
Yeah. So
All my stuff has been zeroed, and for some reason, the locator at the top of the hip is pointing in a weird direction. I think that's the main cause of it. I have no idea why it's doing it.
mine's not. Mine's doing exactly what it should be doing. Because mine is the locator at the top. Ooh, that's fun. Mine is pointing right where it should be.
Right, it's pointing there.
Yeah.
Oh, okay, I see. But then that shouldn't be. But that shouldn't be up there.
What shouldn't be up there?
What's it called? The goal shouldn't be there, right?
Yeah, no, the goal is being transformed somehow. And I need to figure out where in my, the goal should be way down here. And I'm thinking maybe, let's see. So it's receiving, oh, okay, this is my fault. I don't think I zeroed out the transformation of my left ankle control. Is that it? Is that the culprit here? That's not the culprit. I'm going to break this just because I want to. No. Well, I'm intentionally not being in setup mode because I want to see how everything is influencing each other. Yeah, that's amplifying the problem. Okay. I'm sure I'm not sure. I'm 100% certain that I messed up along the way. Okay. At what point did I mess up? Hold on a tick. Oh, here's my entire problem, and I think this may just be Nope, I take that back. All right. So why in the world? That one's there, that one's there, and that one's there. All right, I refuse to lose, and I don't know what my problem is. And this is why I recommend that you always have multiple versions of your project file. I don't know where it went wrong, so I'm just going to redo it real fast. Sometimes that's just the solution. Is just redo it real quick, because after a while you get really good. At solving your problem just by redoing it. I really don't know where I went wrong. This is my big challenge. Walking and chewing gum for me has never been my strongest suit. And this stuff is wildly complex. And if you're off in sequence, it is a challenge. Okay. All right, cool. Let's try that. Cool. All right. There we go. Boom. Inverse kinematics. So I'm not in setup mode. Assign IK. Add goal. Cool. Rock and roll. Okay. Let's zero out the positions of my goal. Maybe that was the step I missed up earlier. Zero out position rotation. Excellent. Let's give it a good name. Left leg. IK. Goal. Cool. All right. Create our 4 little locators and create one real fast. Just for clarity's little ankle. Okay, so I got my 4 locators. I'm happy. Let's get them into place. Ankle is going to go on the ankle. Ball of the foot is going to go on the ball of the foot. Toe of the foot is going to go on the toe. And heel. It's going to go behind the foot. There we go. That's good enough for me. Now let's zero everything out. Okay, let's parent them. There we go. There we go. Excellent.
As far as I can tell, it's happening when I parent. The left IK goes back to control.
Yeah.
Fine up until that point.
That may be it. Let's see. Okay. Let's do my constraints real fast. Position constraint. Ball joint, toe locator, do our direction constraint. Okay. Parent the IK goal to the ankle control. I'm good still. For me, I'm working. I'm rocking and rolling here. Yeah, I'm good. I'm good up to that step. Let's go return back to setup mode. Now the only thing I haven't done at this point, I haven't done the pole vector for the knee. That may be getting in the way. That's that structure. That'll do. Now I gotta go find the direction constraint. Set it as an up vector. Here we go. Do some parenting. Oops. Let's see. So far, so good. Hey, it doesn't break. There it is. So I'm wondering if it's the knee stuff getting in the way, because that is working as advertised. Oops. Yeah, let's do the knee second. And actually, in my directions, I did the knee last. So I should listen to myself more often. But that's working the way it's supposed to be working. Yep. Yeah, and that's it really is the desired goal. So we can grab the heel, rotate that way, rotate that way. I can just bring the heel up, and it moves the entire leg. I can rotate it down. It gives me a tremendous amount of control. I can even still go in, grab the toe, continue deforming and bending it with the heel rotation as it is. It's kind of strange. But let's put that back down, reset its rotations. Yeah, there we go. And we're working. There we go. Yeah, no problem so far. Yeah, I'd do the knee last.
Can I just erase the knee stuff and then?
Yeah, you try just removing it, deleting it, and see what you get. Yeah. Let's get the knee in there real quick. That way we're all on the same page here. All right. So the knee. Let's do the knee real fast. Get that working. Create a new locator. This is the new root left leg. Okay. Match position. Drag that up to hips itself. Excellent. Okay. Zero out its transforms. Excellent. We'll create another locator. This is going to be the knee now. I haven't done the knee yet. Get it where I want it to go. Excellent. And now, once I got the knee locator in there, I can start, I forgot to zero it out. Now I can start making the constraints, okay? So I want to constrain the new root leg left to the directional constraint, to the IK goal. Directional constraint. Oh, I hear myself talking, that's odd. I want to assign the knee as the up vector. There it is. Of course, I haven't been doing any of this in setup mode, which is major problems. There we go. I'm going to go back in time a step because I was doing a whole bunch of stuff out of setup mode, and that is usually danger, danger, danger. Sometimes I get ahead of myself. There we go. Okay, that gets directional constraint to that, and that. Now become the up vector. There we go. I'll insert it in. Okay. There we go. Ah, there it is. Doesn't do any sort of wacky transformations. And I get the full range of motion that I'm after. So big takeaway from the little problem that we ran into is do the knee stuff last. Okay? Do the leg, the IK goal, the feet, and then do the knee last. Okay? That'll seemingly resolve some of the problems that some of the twisting issues that we're getting into. So point being, follow the directions. Follow the sequence that I gave you guys in Canvas, and you'll do just fine. All right, questions. Excuse me. Yes, sir.
Well, I'm able to make the foot move, but I don't believe this is allowing me to do all that you did. It's just confusing.
Yeah, it's pretty in-depth, okay? So here's what I would recommend. Really, follow the instructions that I gave you on Canvas, that step-by-step sequence. That's going to be your guide for this, because if you think about it, you're going to have to do this whole thing over again on the opposite side of the foot, right? Crazy deals, crazy times, okay? So if you look at the big context of what we're trying to do here, many apologies. Let me pull up. I think I don't have green dude selected, so we'll just have to. Here, I'll just explain it. Okay, so for your homework this week, here's the big picture goal, is that you need to go in and insert a whole series of control locators for the waist up. You're going to mirror what we just did for the waist down, IK handles for the legs, reverse foot locks for the feet, okay? And then for the waist up, wherever you have a point of rotation, an area of the rig that you want to control, insert in place a new locator. Because remember, for our animators, we don't want them touching our joints, right? We don't want them touching our mesh, and we don't want them touching our joints, okay? So we need to go in and create a whole series of new control locators that we can insert into the existing skeletal hierarchy that will control the rotation of the elements that we're after. Okay? Insert in place is your friend. Okay? Match position, kind of like what we did for a number of the locators here. So, like for example, if you have the skeleton for your arm established, right? You can match position, that new locator, to the location of the elbow joint, right? What's next? Zero out its transforms. Okay, so it thinks that its current location is its bind pose, is its default pose. And then insert that locator into the hierarchy so we can control just that one joint and rotate the locator, not the joint itself. Okay? It's going to make it very, very easy for our artists and animators to go in and control what we want them to control. Okay? Does that make sense to folks? That's the big picture idea. And you're going to do this for pretty much all the joints in the spine, the neck, and the head. How are you going to easily control the head? All right, good question. Okay, and then the fingers too. Now, for those that are really up to the challenge, creating custom user channels for the fingers is a great way to have the fingers be posable without having to go in and select each individual joint. Right? If you go back to our set-driven keys module, we spent a couple weeks talking a lot about creating custom user channels and set-driven keys. Right? That's going to be the path to success on the fingers. Okay? Because I don't want to have to go in and like rotate each individual joint just to do this, right? What's the range of motion on a finger for most fingers? Just this. That's all they do, right? They just do this. That's, you know, from time to time we'll have to do that, but that is very rare in animation to be able to go, right now. You just get wave your hand like that, right? So all we really need to do is do this with our fingers, just to curve it. A set-driven key, right, making a relationship in the channel links section, remember the whole module, will allow us to assign the rotation values to a singular custom user channel. Okay? And we'll have a slider in our master controller that allows us to do this. Sound good? Everyone kind of feeling it? Yeah? All right, that's your homework this week. That's your homework. Okay? Luckily, you should have some experience on the toughest part, okay? The waist down is the toughest part of this entire process. We've already done it a couple times in class today. So use this in-class experience for your lab, right, and get it done. Actually, for the lab itself, and I forgot to mention this earlier, what you just did is your lab assignment today. So congratulations, okay? Right there. If you've been following along, and you should have, okay, you're pretty much done with your lab. Make sure you submit this project file back to this lab assignment. It'll be the easiest 25 points that you've ever received. If it's not working yet, you know, we still got about 20 minutes in class today to get it kind of up and running. And also there's the expectation that you spend outside of class time on your lab work. So if you're not done with your lab, well, you can finish it up real fast before you jump into your homework. Okay? Questions, comments? Yes, sir.
I have a question. You need to see it.
Okay. Before my brain walks away from what we're doing this week as far as assignments, I think in my mind it goes without saying, but the homework is the green dude, right? It's the continuation of the green dude. You've already done the skeleton and the paint weights for the green dude. Now it's time to go in and do inverse kinematics and all the other control locators for the green dude, okay? And then your lab assignment was that little leg that we've been working on for the past couple hours. Sound good? Everyone understanding what we're doing? Please download, as Alan did earlier. You can even print out the instructions in the lab for free, by the way, okay? If you want to print them out, okay? Then make sure you save that PDF, follow it to the T, and you'll be able to get that part of the assignment done pretty easily. In addition, I've live streamed 100% of the content today. If you really want a good illustration as to how to put the waist down together, watch the last 20 minutes of the live stream. I just did it for you guys, okay? All right. Questions, comments? As always, good luck. Okay? I know that there's going to be some questions. Please visit me during office hours this week and talk with Chris. Cyrus over in the design lab is also a super ninja when it comes to rigging. Okay? So hunt him down. Seek him out if you have questions. And of course, please come find me during office hours or email me your questions. I'd be more than happy to help.